Today we're having a look at quadratic functions. Quadratic functions, we did a bit on this last year. And I'd just like to remind you, they always have something, it always looks like, hang on, I'll scroll down. It's always going to look a bit like y equals a number, then an x squared term, another number, this doesn't necessarily have to be positive by the way, and then an x term, and then another number. Just like they have here. And that's kind of the generic form for a parabola. And parabolas are going to end up looking, if I've got my y-axis and my x-axis, they're going to end up looking, maybe it might look like this, and you know, it keeps going that way and that way. Or maybe it's going to look like this, and it keeps going that way and that way. And I like to think of them as a happy face or a sad face. And I like to think of them that way because to tell which way up is the parabola, if the number in front of the x squared term is positive, it's a happy face, it's positive, it's happy, it's a smiley face. So the first question that we're asking about a parabola is it, and we call that concave up. So hang on, here, concave up, a spoon's facing upwards, it's a happy face. Or concave down. Which is sad. So again, the way we tell if I really hate the way this is writing. So if A, which is the coefficient of x squared, is positive, it's happy. So it's going upwards. Otherwise, it's going downwards. Which is sad. So I'm going to draw the super generic form of a quadratic for you. If I have my y-axis and my x-axis, then y equals positive x squared is just going like that. But y equals negative x squared is going down like that. And it's going to keep going. Like, I just can't be bothered drawing it all the way because obviously you would never end. Its domain is all real R. Yeah. So that's the first question. If it's going up or down. The second thing you need to the second thing you need to figure out is, what is the y-intercept? Where does it actually cross, where are we? The y-axis. Does it cross the y-axis? So if I'm going to draw my y-axis, x-axis, we're trying to figure out where our generic y equals ax squared plus bx plus c, which maybe, you know, I'm going to do like here. That's just a generic one. We're trying to find this point here. And at that point, x always equals 0 because along the y-axis, So along the y-axis going downwards, up and down here, x always equals 0. So what we actually do is we substitute x equals 0 into our equation, and that'll leave us with what y equals. So if we did that, y equals a times 0 squared, a is just whatever number is in front of the x squared, plus b times 0, again, b is the number just in front of the x, plus c, well, the 0 squared and 0, like, they'll just disappear, those terms, because anything times 0 is 0, so you're left with y equals c. So if you've got the equation like y equals 2x squared, take 3x plus 1, you know straight away your y-intercept is y equals 1. We'll do that in an example later on. Third question we want to do. Third question we need to know. Wait, why would I do that all the way over there? The rest haven't been. Third thing we want to know is, what are the x-intercepts? This is the hard bit. Now, if we were to do another axis, y, x, I should have labeled that there, and a generic, just any generic parabola, the x-intercepts are literally along this line, and they're going to be here and here. But we don't know what x is at these points yet. We will find out. But what does y equal at all these points along the x-axis? It equals 0, because we're not up, we're not down, we're exactly on the x-axis. So we sub in y equals 0. So we get 0 equals ax squared plus bx plus c. Or we could just write that the other way around, and we're more used to seeing it the other way around. Ax squared plus bx plus c equals 0. And then to solve that, we actually did a lot of solving this back in chapter 1. Then to solve that, we then factorize. Or we can use the quadratic equation. PJ's just brought me a coffee. Hi PJ, I'm recording a video for my year 11s. Would you like to wave at them? If you come and wave at the screen. Oh, hang on. There we go. Thank you. It's like a Stan Lee cameo. Yes. Thank you. So we can then factorize, or we can use the quadratic equation. I can tell you which one I usually do. Oh, I can't for this. And I'll remind you what the quadratic equation is. X equals minus b plus minus the square root of b squared take 4ac all over 2a. Are you at the point that you can say that off by heart yet? Okay. So we'll do some examples later. The fourth thing we have to then ask ourselves, so now we know which way up it faces, we know where it goes through the y-axis, we know the 2 points where it'll go through the x-axis. We then want to figure out whereabouts it's going to turn about. So that's the vertex. No, that's the axis of symmetry. We're going to find the axis of symmetry because that'll tell us the vertex. I was jumping ahead of myself. So for what is the axis of symmetry? So I'm just going to draw a few as examples. Don't read too much into these. I'm not drawing them perfectly. Arrows. Thank you, Mrs. Graham, my 8th grade maths teacher, for being so dogmatic about arrows. Y, X, Mrs. Graham. She's a great teacher, but she smelled really bad. She was a smoker for a very long time. So here's one example of one. Here's another example of one. Here's like a third example of one. They may not even go through the x-axis at all. That's fine. Each time, to figure out the axis of symmetry, we're trying to figure out like whereabouts it turns around. If I held a mirror to one side, how it would reflect perfectly the other side. See how my face, slightly different both sides, parabolas are not. So this one, it's about there. This one, it's about there. This one, it's about there. And the quick, easy, dirty method is it's halfway between the x-intercepts. Oh, I need to scroll. The axis of symmetry is always halfway between the x-intercepts. We've actually also got a shortcut for that. It's x equals minus b over 2a, where a is the number in front of the x squared and b is the number in front of the x. Yeah? That's just a handy formula for that one. And number 5, we need to know the turning point, which is also called the vertex. So that's the point you're going, hang on, we're going down and then we go back up. It's the bit down there. Is the vertex. I know in maths we have lots of different names for things. That's because it was developed by a whole bunch of people at different times, in different places. You could almost say maths was discovered, not invented, if that makes sense. So the vertex is the... Oh no, I should draw an example, sorry. So if I draw an example, actually I'll draw 2 examples. Arrows, thanks Mrs. Graham. Weird story about Mrs. Graham. She used to be a nun before she dropped out of being a nun and became a teacher instead. And maybe my other one is just a bit of a sad... There we go. And we figured out the axis of symmetry. And it's down here that we're trying to find. So you substitute the x coordinate, so the axis of symmetry. Whoa, why is that? That went weird. Actually, axis of symmetry, which also comes out as x equals minus b over 2a, back into y equals ax squared plus bx plus c, and find... I hate the way this is writing. I'm going to go back to nope. And find the y coordinate. That's it. They're the 5 steps. Once you've done that, you can sketch. I'm going to record 2 examples for doing this in a different video. Thanks for watching.